Question 8.1 is about linear functions. We want to be able to graph them, and then we want to be able to write the equations of the linear functions if somebody describes them to us. That's going to be the more challenging part. From your blue note sheet, you're going to find several formulas that are going to be helpful. You're going to need to be able to find the slope of a line. Usually letter M is used for slope, and it is y1 minus y2 over x1 minus x2. Or at least that's the version I use. In MATLAB, you will find that they will use y2 minus y1 over x2 minus x1, and it makes no difference whatsoever. I just have this personal preference for one coming before two. So that's the way I do it. Okay, and this is going to be some information that you did a lot of in Math 307, or at least part of it will be. All right, equations of lines. The one that you used in Math 307 was y equals mx plus b, which is called the slope-intercept form. And we will use that a good bit. The b value stands for the y-intercept, where it crosses the y-axis, and m stands for the slope of the line. We'll use that in a few minutes. If you took Math 307, then you are familiar with that format. But another format, which we're going to use a good bit, we don't discuss in Math 307, and it is called the point-slope form. Point-slope form. And it looks like this. Y minus y1 is equal to m times x minus x1. Now you see in that two sets of x's and y's. There's an x and a y that are plain, kind of generic, and then there's an x and a y that have little ones, little subscripts. And you will see in a few minutes that we use this form if I describe a line and I say it goes through a particular point and has a particular slope. But for right now, if you just write that down, it is on your blue sheet. Okay, now there are other equations of lines. So far, I have slope-intercept and I have point-slope forms. We also have y equals some number, and that is the form of a horizontal line. If your line is horizontal, then it is y equals a number. If your line is vertical, what does the equation look like? X equals a number. Those are going to be the four different forms that you're going to use in this lesson. Slope-intercept, point-slope, y equals a number, and x equals a number. There are two other little bits of information that you need to know about some formulas, and it is about parallel and perpendicular lines. And once again, if you took Math 307, then you're somewhat familiar with this. Parallel lines. What appears to be true about the slopes of parallel lines? Okay, the two lines do not intersect. Now let's go further. What about their slopes? Pardon? They're the same. Slopes are equal. And mathematically, what we would say is M1 equals M2. Slope number 1 equals slope number 2. They have the same slope. An example would be, what if one of the lines is y equals 2x plus 3, and one of the lines is y equals 2x minus 4. Look at these two lines. Look at their slopes. Do you see that their slopes are the same? And that means that they are, and that's way too fat to be writing, parallel. Let's look at two lines which are perpendicular. And if the lines are perpendicular, then they intersect at right angles. Does anybody remember what's true about the slopes of perpendicular lines?
It's the same slope, but one's positive.
Okay, you have got one of the two criteria right. All right, so slopes are opposite, because she said one would be positive and one would be negative. That's one. What's the other condition? Did somebody whisper it? They are opposite reciprocals. Whoops. Okay, it's back to doing that weird thing. Opposite reciprocals. An example would be if one of the slopes is 2/3, the other one would be negative 3/2. On your note sheet, what it says is M1 is equal to the opposite of 1 over M2. Opposite reciprocal. Okay, I want to say just a couple of other little things. I mean, this is a lot of just information, and all of this, except for the pictures, is really on your blue sheet. Okay, a couple of other things. Slopes of lines. The slope of a line is a critical piece of information about the line. And there are 4 different kinds of slopes that can occur. If your line slants up and to the right, yes, slope is positive. If your line slants down as you go from left to right, a falling line, slope is negative. All right, now the last 2 kinds of lines that you can run into are vertical, and well, horizontal is the first one and vertical is the second. So at the risk of repeating myself, I'll do it. Those of you who are with me in 307, sorry, going to tell you the ski story again. Okay, I went skiing once. It was a bad experience for me. No matter how hard I tried, and I did take the lessons, I always ended up flat on my back. I just could not stay up flat on my back. I looked a lot like the picture here of the horizontal line. My brother-in-law referred to me, and it was lovingly, as a big 0 when it came to skiing. Well, he was accurate. I wasn't even offended. It was an accurate description. I was a big 0. So you can remember that the slope is 0 for a horizontal line because you can envision and snicker about that being me. Okay? Now, vertical. Can you possibly ski on a vertical surface? You can give it a try, but you will just crash. Okay, so this one is impossible. The slope is undefined. So sometimes students have a little trouble remembering which one is 0 and which one is undefined. Well, you just remember that the horizontal one is me, and I was the big 0. And this one is impossible. Okay? And something else just to recall, the first two lines that I have drawn, both could be written as a y equals mx plus b. They are slanted lines. The horizontal line cuts through the y-axis. It will always be written as y equals some number. And the vertical will always be written as x equals some number. And of all of these, one of them is not a function. Which one? Which one is not a function? You bet. This is the only one that's not a function. It would fail the vertical line test because it is a vertical line. Okay, I believe that is everything you ever wanted to know about and more about slopes of lines. So now let's look at what MathLab wants to ask you. Question number 1. And I will just make sure that I allot enough time to go into my MathLab and show you how to use the graphing tool for those of you who have never done it before. Okay, it says graph the linear equation. All right, and this has been pulled straight out of a MathLab question. First of all, if you have mature eyes like I do, you probably want to click this little button that says click to enlarge. Okay, just so you can see better. You young people probably don't need that, but it's helpful for me. All right, it says to graph this. What I want to do is review, or maybe teach you for the first time, about using slope-intercept to graph. Okay, the function is f of x is equal to 4x. Now, although it's in function notation, I'm usually going to think of it as y equals 4x. I am going to compare it to slope-intercept form. Slope-intercept form is y equals mx plus b. And I'm going to compare it very carefully. I want to notice that the 4 is in the place of the m, and then notice that there seems to be nothing in the place of b, which means what could be sitting there? A 0. Now, B stands for y-intercept, where the line crosses the vertical or the y-axis. M stands for slope. Those letters don't make a lot of sense, so I just made up my own reasons that they used M and B. I'm going to let B stand for begin at that value, which is 0, on the y-axis. B for begin on the y-axis. M, I'm going to say, stands for move according to some slope directions. Okay, what number is the slope in this problem? 4. Slope is always written as a ratio. So I'm going to put it over something. What can I put it over? 1. Now, I don't know how much you've thought about slope lately, but slope is the rise over the run. It is the change in y over the change in x. The numerator is the vertical component. Since it's a positive 4, I'm going to draw an up arrow. The denominator of the slope is the horizontal component. Because it's positive, I'm going to draw a right arrow. Okay? Now, if I go to the grid, that is provided. Now, if you don't have a grid and you're trying to take notes, then you're busy drawing one of these, drawing that on your notebook paper. Let me try to make this a little larger for the class. Okay, the M and B, begin with the B value, begin at 0 on the y-axis, and that is 0 on the y-axis. Move, according to the instructions, from that point up 4, right 1. So I will go up 1, 2, 3, 4, right 1, and do another point. You can repeat that activity as many times as you want, up 1, 2, 3, 4 over 1. Or just do it the one time. Then get us some kind of straight edge and put it in there. Now, I didn't have any trouble doing it on my computer because I'm using a fancy schmancy computer and a program called OneNote. But it's not like that with MyMathLab. With MyMathLab, you're going to use what's called a line drawing tool, and it looks like this. Here's a button, and it has a little line in it with 2 little dots. Okay, you're going to click that button. You are then going to move your mouse until you're where you need to begin and click the left-hand button on your mouse, and that anchors the beginning point. Then you're going to move your mouse according to the instructions up 4 and over 1, and you're going to click that button a second time. Okay, so you click where you begin, you move, and you click it a second time. It will draw the line for you. It'll be perfect. And I'll demonstrate that in a minute, or at least I'll try to. Everybody okay on this? Slope intercept. Let's look at number 2. We are asked to graph y equals, well, it says f of x, but I'm going to think in terms of y. Y equals negative 3x plus 5. Okay, where will I begin? At 5. I will begin at 5 on the y-axis. M, how will I move? Well, what's the number? Negative 3. Since it doesn't have a denominator, you have to give it one. What does a vertical negative 3 tell you to do? Go down 3. And then a positive horizontal, go right 1. B for begin, M for move. Begin at 5, it must be on the y-axis. So here is 5 on the y-axis. Don't put it on the x-axis, put it on the y-axis. From there, I move down 3, 1, 2, 3, and right 1. I can do that again. Down 1, 2, 3, right 1. Now, literally, when you do MathLab, you don't get to keep repeating this. In MathLab, what you would do, and I'm going to do this in red, I would begin at 5. So I would use my mouse, I would go up to 5, and I would click my mouse on the left-hand button of my mouse when I'm sitting right there. Then I would move down 3, right 1, and I would click my mouse again right there. That's all you get to do. The line is drawn. Then you can ask it to check it for you. Is that okay? By the way, this has a negative slope. Do you see that it is a falling line? That's what should have happened. In number 1, the slope is a positive 4. Do you see that it is a rising line? Okay, moving on. Number 3. You're asked to graph y is equal to negative 1/3 x. When you're given a fraction for the m value, great. You don't have to put it over 1. But you're given a negative value, so we need to talk about that. Where will I begin? Okay, I will begin at 0. Because there is no b value written, I know it's a 0. Begin at 0 on the y-axis. How will I move? Well, the slope. The slope is negative 3. We talked a good bit when we were in chapter 7 about where does a negative sign go with a fraction, and you have choices. Out in front is not very useful for slope. So what I'm going to do is I tend to put it, well, with the top. So when I have a negative sign on a fractional slope, I personally tend to always attach it to the numerator. Okay, which means what? I'm going to go down 1 and right 3. So let's graph. All right, where will I begin? At 0 on the y-axis. So I begin right there. And how do I move? Down 1. Right 3, which will put me right there. Now in MATLAB, that's all I get to do. Click for the beginning point, click where I end up. But I could do down 1, right 3 again, and get another point if I wanted to. I had a negative slope. Do I have a falling line? Yes. By the way, I'm emphasizing slope-intercept. MATLAB doesn't know how you're getting these lines. So if you chose to make a t-chart, you could get 2 points, plot the first one, move to the second one, click there, you're done. I just want you to practice slope-intercept. I know how important it is in college algebra. Yes, sir.
And you put the negative one in there.
Yes. It actually would not. So let me just show you. His question is about, I put it as negative 1 over 3. But what would happen if it was 1 over negative 3? Okay, this would tell you to go up 1 and left 3. So if I use blue to do that, if I start here, if I go up 1 and left 3, although my line's a little bit off, can you see that I would still, if I were more accurate, be on the line? I just used a big fat marker and it didn't work quite as well. But excellent point, because you should be able to go down and right or go up and left and you'd be on the same line. And it's your choice. Number 4. The function that we're asked to graph is y equals 1/3 x plus 3. I'm not going to write everything I've been writing for all these problems. Where will you begin? At 3, and hopefully we all know it's on the y-axis. And how will you move? Well, the fraction is 1/3. So up 1, right 3. Begin at 3 on the y-axis. From there, go up 1, right 3, another point, done. And if I had wanted to, I could have reversed both those directions. I could have gone down 1, left 3. And if I did down 1, left 3, if I drew accurate lines, I would still be on it. A very sharp pencil and a nice straight edge does a lot better for graphing. By the way, slope is positive. Did we have a rising line? Okay. We are done with the graphing. Okay, so the first 4 questions get you to thinking about graphing. Now, think about taking a test that is multiple choice and has graphing. It will have a function. You will be asked which of these is the right graph. And I would suggest that on your piece of paper, you do the little graph and then look up and see which one matches yours. Okay, moving on. We are about to now move into the part of the lesson which is about finding the equation of a line. And I'm going to nickname this part of the lesson, What's My Line? Now that used to be a TV show. That's actually been 2 TV shows. One of them was so long ago, it was in black and white, and none of y'all probably ever saw it. I mean, it was really old. I was a kid when it was on, so you know TV had just been invented. Anyway, then there was another version of What's My Line that was on, actually I think a few years ago, and it was more of like the MTV version or something. It was a little more upbeat. But we're going to play our own version of What's My Line. And next time you have a party, you could play this game. Everyone will leave your party. You will be labeled a nerd, but you know, you'll save on expenses of food and beverages. Okay, so here's our game. I'm going to tell you about a line, and then you're going to tell me what the equation is. Doesn't it sound like fun? Oh yeah, y'all are all smiling. Okay. Now, sometimes I'm going to give you everything you need to know and it's going to be super easy. Other times, not quite so easy. What tools are you going to use? You're going to use your blue sheet or all these notes that you wrote down. Okay, here we go. The first one, it says use function notation. Well, I don't really have to worry about that because my math lab already has function notation. To write the equation of the line with the given slope and y-intercept. So what's given is slope. M is -8. The y-intercept. Now the y-intercept is the point 0, 5. If the y-intercept is 0, 5, then what is the b value? It is 5. If the x is 0, then the y value is the y-intercept, 0, b. All right, so b is 5. Think about what you're given. You're given slope and an intercept. Back in the tools, do you have something that's called slope-intercept form? What you're given tells you what to use. If you're given slope and intercept, then use slope-intercept. So use slope-intercept form, and I'm going to write it down. It is y equals mx plus b. You need to plug in for m and for b. Do you know what to plug in? And please say yes. All right, what is the slope? -8 times x plus 5. Done. There's your answer. Now, in Math Lab, it will not say y equals, it will say f of x equals -8x plus 5. It doesn't matter. F of x, y, they're the same thing. Is that okay? I described the line, you gave me its equation, but I gave you the best information I can give you, which is slope and intercept. By the way, slope is always what you need to know first. Okay, let's keep going. Pardon? The 0 tells you when you have the point, let me write it right over here. When you have a point that is 0, comma, a number, what that tells you is that you are on the y-axis. Because if your x is 0, then you didn't go right or left. You are on this axis. And that means it's the y-intercept. So all the 0 did was tell you it was the y-intercept. And that'll be another question in just a minute. All right, she's ready for the next kind of problem.
So if x is 0, it's always y-intercept?
Yes, sir. Yes. If the point given has an x of 0, then the other number, the y value, is b. And they may not tell you that. You may have to figure that out on your own. All right, let's look at number 6. This time, you are told that the slope, m, is -6, and the y-intercept is the point 0, -5/7. So what is b? -5/7. And you may think, well, that's kind of a silly question, but please remember, and y'all have made a big deal out of it, and that's great, that if the x is 0, then the other number is b. And we have to look at a problem in a minute where it's not like that. So you are given slope and the y-intercept. So what do you use? You use the slope intercept form. What you're given tells you what form to use. So y equals mx plus b. Y equals what? -6x minus 5/7. That's about the easiest kind of problem there's going to be, where I give you m and b. Are you ready for number 7? Oh, same kind. Little hard to read. It's a multiple choice question. It says use function notation to write the equation of the line with the given slope and y-intercept. You are given that m is 3/4 and b is, well, let's see, it goes through the point 0, 0. So what is b? It is 0. The first 0 tells you that it is the y-intercept. The second number tells you where it's crossing the y-axis. It's b. So if I don't look at these choices, if all I do is think about the line, it will be f of x, or y, equals what? 3/4 x plus 0. But would anybody write plus 0? No. Of the choices, the only one that's correct is choice B. It is the same thing. Slope and intercept makes it easy. You're going to use y equals mx plus b. Let's look at 8. Find the equation of the line with the given slope. Oh, here we go. Containing the given point. All right. We are given m equals 3, and it goes through, and I do understand that that is not how you spell the word through. It's a short version. 7, 4. Do you have the y-intercept? No. Because what would this 7 have to really be for it to be the y-intercept? A 0. That is not the y-intercept. That is just some point on the line. What do you have here? You have slope and a point. Slope and a generic point. I'm going back to my notes. Do you see something called the point-slope form? Point-slope form. If you have the slope and a point, you're going to use point-slope form. Now, we've not used it before, and it is called, or it is written, y minus y with a little subscript 1 is equal to m times x minus x1. There are 2 points listed here. One of them is just a plain old xy, and the other one is an x1, y1. The point that you're given is always treated as x1, y1. The other x and y just remain in the equation. So here we go. Do you see that we have the, oh goodness. Do you see that we have the slope? Do you see that we have an x1 and a y1? Then we should be able to plug in here, here, and here. So let's do it. I have general y minus, what is the y1 value? 4 is equal to the slope value, 3 times x minus 7. If I'm supposed to write this, and they always say this, to write it in function notation, then that's another way of saying always have it in the form y equals. So I'm first going to use the distributive property. Y minus 4 is equal to 3x minus 21. Almost got weird with a multiplication. Add 4, and I get y is equal to 3x, what? Minus 17? And that's the equation of my line. Remember the game we're playing. What's my line? You tell me something about the line, and I'll tell you its equation. This one got a little harder because I didn't just give you m and b. I gave you m and a point. But we have a tool for that. We have the point-slope form.
So is that always going to end up back in y equals mx plus b?
Yes, ma'am. Her question, is it always going to end up back in y equals mx plus b form? Yes. Yes. Now, you could encounter some textbook or some instructor that wants it in some weirdo form. There is something called general form, but not in this class and not with me. With me, I love y equals mx plus b. All right, let's look at 9. We should find a very similar question. Find the equation of a line with the given slope containing the given point. All righty, we are given m is equal to -6, and my line, my mystery line, goes through 8, 9. What do we have? We have a point. We have the slope. So let's use point slope form. Y minus y1 is equal to m times x minus x1. That's going to be y minus, what am I going to put in the place of y1? 9 is equal to negative 6, parentheses, x minus 8. Now, it turns out that the examples that came out of Math Lab this time have points that tend to have positive coordinates. Please be careful, because if one of these is negative, then when you put, say this had been a negative 9, you would have y minus negative 9. What's minus a negative mean? It really means plus. So just watch out for that. It could happen. All right. Simplifying this, y minus 9 is equal to negative 6x plus 48. Add 9, because I'm trying to get it in the form y equals, and I have y equals negative 6x plus 57. I wouldn't want to have to graph that line, because I'd have to draw a grid that extended up far enough for me to graph 57. And I wouldn't want to do that. Is that okay? All righty. 10. All right, new problem. We're still playing the game. What's my line? But this time, you're given 3, 4, and 5, 8 as points on the line. Oh my goodness. You're given 2 points. Now, there is a possibility that you could be using a book or having an instructor that let you or ask you to use something called the 2-point form. And believe me, you don't want to work with the 2-point form. It is nasty. I could show you. I will. 2-point form. We're not going to do this. In fact, I'm going to erase this, okay, after I write it. It is y minus y1 is equal to y1 minus y2 over x1 minus x2 times x minus x1. And if you don't think, people get confused about what's a 1 and a 2 and a... Now, maybe I'm just prejudicing you against that form, and I shouldn't. It's a legitimate form, but I've just seen too many people fall apart with it, so I don't do it. What in the world? What did I tell you you always had to find first about a line if you were looking for its equation? The slope. Okay, so this could be a 2-part problem. Part 1, find the slope. And although we haven't done it in here, we do it in Math 307. We use the slope formula. M is equal to y1 minus y2 over x1 minus x2. The y's are always the top of the ratio, and the x's are the bottom. So this is going to be 4 minus 8 on top over 3 minus 5 on bottom. Okay, so 4 minus 8 is negative 4. Whoops. And 3 minus 5 is negative 2, but negative over negative is positive 2. I'm not done, but I sure need to know that the slope is 2. Okay, now what do I have? Because what I have is supposed to tell me what to use. I had 2 points, and the only thing I know that I can do with 2 points is find the slope, and I did. Now what do I have? I have the slope, and do I have a point? I have 2 points. What we're going to do for part 2 is pick a point. And the nice thing is, it doesn't matter which one you pick. Okay, pick a point. Either 3, 4, or 5/8? Okay, 3/4. So 3/4, that's my point. M equals 2, that's my slope. So how about point slope? Use point slope. You use point slope a lot. Y minus y1 is equal to m times x minus x1. So that's going to be y minus 4 is equal to 2 times x minus 3. That's y minus 4 is equal to distributive property, 2x minus 6. Add 4, and y is equal to 2x minus 2. Now, I hope it's not a waste of our time. I just want to show you that you could have picked the other point. Sometimes I don't take time to do this and I just tell people believe it. But what was the other point? 5/8? Because I don't know about you, but I might really doubt that you would get the same answer. So if I choose, now please keep in mind that you don't need to do both of these. You just do one or the other. So I have y minus y1 is equal to m times x minus x1. Somehow I'm supposed to get the same equation. All right, so I have y minus 8 is equal to 2 times x minus 5. So y minus 8 is equal to 2x minus 10. Add 8 to both sides, and I get y equals 2x minus 2. It could be, yeah. You could do the other one as a check. Do either way. Yes. Or you are really creatively wrong. Is that okay? All right, I think we'll make this one be our last one for today, and then we'll finish this lesson up, and I will show you tomorrow. We need to start class by doing a couple of things in my math lab, and especially I need to talk to you about the online testing. All right. This one says find the equation of the line passing through, this is number 11, the given points. So you are given negative 1, 3, and 0, 1. Okay, what do you absolutely have to find out first about a line? Slope. So part 1, find slope. And we have a formula for that. M is equal to y1 minus y2 over x1 minus x2. Remember that the y's are on top and the x's are on bottom in the slope formula. That gives me 3 minus 1 over negative 1 minus 0, which is 3 over negative 1. The slope is negative 3. Pardon?
3 minus 1.
I was doing a little of that creative math. 3 minus 1 is usually 2. Thank you. So that's negative 2. Because the whole problem falls apart. It's all wrong from there on if you mess up like that. All right. What do you do next? Pick a point. This is part 2. Pick a point. I don't want to do both versions this time. Which point would you like me? Yes, ma'am.
Since the x is 0 and the point is in the y-intercept.
You just made my day. I think this might be the first time in teaching this lesson that anybody has actually said that before I got through the problem. She looked at this and said, hey, since the x is 0, doesn't that mean that the b is 1? I'm very impressed. It usually takes doing this for actually a lot of years before you're tuned in to noticing that. Because this is 0, this is b. Okay? Which means, if you notice, because I want to show you what to do in case you don't notice. If you notice b is 1, then you're home free. Y equals mx plus b. Y equals, you had the m value, negative 2x. You got the b value was given to you if you were observant enough to see it, 1. Problem done. And those of you in class can't read any of that. That would be very acute observation that a whole lot of people don't make. That doesn't make anybody a stupid person. It just makes her exceptional. Okay, if I've sufficiently embarrassed you now. All right, going back, let's just say that the average person doesn't notice it. Pick a point. What point would you pick? Oh yeah, you'll pick 0, 1, and you still won't notice that you've got the y-intercept in front of you. It's okay. That's okay. It still works. All right, so now you say, okay, I will use point slope. Y minus y1 equals m times x minus x1. The point we picked was 0, 1. So it's y minus 1 equals slope value negative 2 times x minus 0. So that's y minus 1 is equal to distributive property, negative 2x. What's negative 2 times 0? 0. So I'm just going to put it there even though I hope you wouldn't. Then you would add 1 to both sides, and you'll get y is equal to negative 2x plus 1. And if you use the other point, you would get the same thing. If you just, in this class, we made a really big deal about if the x is 0, the y value is b. But until you're faced with it, you're just not used to noticing that. Okay, I'm going to go ahead and stop now. This will be part 1 of the video. We will do part 2 of the video tomorrow. My schedule's a little off, but that's okay because we're not doing an in-class test on this. So I actually have the whole week to do it.